So example 6, determine the length of the longest metal rod K, which could be stored in a rectangular box measuring 20 by 50 by 30. So the longest metal rod basically should be the diagonal of that cuboid. And let's just call the length of that diagonal D. And we can find it using method 2 of example 1. So D will be equal to the square root of 20 squared plus 50 squared plus 30 squared. And if you plug that in the calculator, that will be 61.6. Okay, moving on. Example 7. So in example 7, so here we have a tree is 8 meters north. So let this be north and let this be east. First of all, we know that north and east are perpendicular. So that should be 90 degrees if you remember compasses. Anyway, so a tree is 8 meters north, so this is 8 meters. And 6 meters east, so this is 6 meters of another tree. So in this case, this means that this will be our first tree, and this will be our second tree. Okay. All right, let's keep on reading. One of the trees is 12 meters, so this will be 12 meters. And the other one is 17 meters, so this will be 17 meters. Find the distance between the trunks of the trees. So for part A, to find, I can use now this color. So we want the trunks of the trees. So that means the distance from here to here. Let's just call it X. So we can apply Pythagoras theorem by considering this rectangle here. This triangle here, not rectangle, this triangle here. So basically X squared will be equal to 8 squared plus 6 squared. So X will be square root of 8 squared plus 6 squared. And then if you plug that in your calculator, that should be equal to 10. Okay, and then part B, so this is 10. Part B, we are required to find the distance between the tops of the trees. So from here all the way to there. Okay, so if this is 10, that means that length should also be 10. Yeah, so this is 10 meters. Now, this angle here should be 90 degrees if this is 90 degrees. And of course, that's 90 degrees and that's 90 degrees. Yeah, and that's the approach that I used to find, yeah, to draw these lines here. Anyway, so moving on, if this length here is 12, it means this length from here to there will also be 12, and which means the remaining length from here to here will be 5 meters to make 17. So what basically you're trying to do here is to focus on this triangle here. If you notice this highlighted triangle, So we want to focus on this highlighted triangle to be able to find the distance between the tops of the trees. And the distance between the tops of the trees can be represented by y. Yeah. So by Pythagoras theorem, y squared will be equal to 10 squared plus 5 squared. So y will be equal to the square root of 10 squared plus 5 squared. Now if you plug that in the calculator, that will be equal to 11.2. That's it. Number 8. A rainwater tank is cylindrical with a conical top. The slant height of the top is 5 and the height of the cylinder is 9. Find the distance between P and Q. So they want us to find the distance between P here and Q, as shown in the diagram. So just move that there. From P all the way to Q. All right, so that's the required length that they want us to find. Well, what we can do here is, first of all, try to imagine a situation whereby we can drop a line from the top all the way to the center of the base, and then we join these two. You can notice that the resulting shape is a triangle, and that's what we want because we want to apply Pythagoras theorem. In fact, this triangle here is a right angle triangle. Well, let's look at some measurements. So basically, the diameter of the base is 8, which means that the radius will be 4. So this length here is 4. But we need the height to find PQ. Now, to find the height, consider this. Suppose we have this as the center of the base of the cone. That will be the radius of the cone. Now, basically, the radius of the cone is same as the radius of the cylinder because they fit perfectly. So the radius of the cylinder is 4, which means that will be 4. So let's start by finding the height of the cone. So step 1, let's find the height of, let the height of the cone be x. So step 1, let me write this properly. So step 1. So find x, and that is the height of the cone. And we can find that by Pythagoras theorem. Remember, x is the shorter side. So the steps involved will be the sum of the shorter side. So x squared plus 4 squared should be equal to the square of the longer side. So which means that x squared will be equal to 5 squared minus 4 squared, which implies that x will be the square root of 5 squared minus 4 squared, and that will be equal to 3. So that's step 1. And then step 2, if this distance here is 3, that means that, and by the way, the distance from here to here is 9. So from here all the way to here is 9. Let me just write that here, that's 9. That means that the entire height of this water tank from the bottom all the way to the top will be 12. So basically what we want to do is to consider this triangle here and use it to find PQ. So that will be my step 2. So step 2, find PQ. And to find PQ, what you're going to do is to consider that triangle that I highlighted, this is 4, and the entire height is 9 plus 3, which is 12. So, and this is P, and this is Q. So basically, PQ squared will be equal to 4 squared plus 12 squared. So PQ squared, PQ just by itself will be equal to the square root of 4 squared plus 12 squared. And if you plug that in the calculator, that will be equal to 12.6. And that will be the length of PQ.